Have you ever wondered why hot chocolate always cools down? Or why ice cubes always melt? Why does energy behave the way it does? The answers to these questions all lead to the second law of thermodynamics, otherwise known as entropy.
It's a pretty tricky concept in physics to explain, so no it isn't. Entropy is just a measure of how disordered a system is. Well, not exactly. You see, disorder is just an analogy for entropy, and while it can be helpful in explaining entropy to beginners, it's pretty misleading. Allow me to explain. A better way to understand what entropy is to use probability. There are quintillions, sextillions, septillions of different energy arrangements, or microstates, that a molecule can have. That is, energy can be distributed throughout a system in many different ways. Entropy deals with how spread out the energy of a system is. The more spread out the energy, the higher the entropy. Oh, I still don't get it. Okay. Think about it like this. Imagine you have a box. Say it's filled with a bunch of balls, half orange and half white. Now, let's arrange them so that all the orange balls are on one side of the box and all the white balls are on the other side. The orange side represents a system with lots of energy, and the white side represents a system with little energy.
So you can think of the orange side as a hot cup of hot chocolate, for example, and the white side as the cooler air surrounding it.
As I said before, entropy can be thought of as the measure of how spread out the energy of a system is. Over time, entropy tends to increase, which means energy tends to become more spread out. When I shake the box, the balls are constantly changing their configurations. This represents the constant change of microstates, aka energy configurations, in a system. Now, if I were to stop shaking the box and look inside, what do you think I would find? Would A, all the balls still be in their original configurations? Or B, would all the balls be mixed up? If you chose B, all the balls will be mixed up, you are correct. Of course they are mixed up. There are billions, probably even trillions of configurations that the balls can have in which they are mixed up, but only one possible configuration in which all the orange balls are on one side of the box and all white balls are on the other.
The same goes for energy. There are septillions of ways that the energy could be configured so that it is spread out between the hot chocolate and surrounding air, but only one possible combination in which all the energy stays within the hot chocolate.
Oh, so that's why hot chocolate always cools down. It's just far more likely for the energy to spread out into the surrounding air than it is for it to stay in the hot chocolate. So that's just what always happens. The energy spreads out and the entropy increases. Exactly. So the next time someone tries to tell you that entropy equals disorder, you can be sure to explain that entropy does not equal disorder, but it is rather a measure of how spread out the energy within a system is. Thanks for watching.